This is Advanced Math 11.4 homework questions. That's Advanced Math, Unit 11, Lesson 4. These are the problems I'm going to go over, starting with 23. Okay, 23 gives us the foci is plus or minus 5, 0, and the major axis length is 14. Find the equation, I believe is what it is asking for here. Find the standard form of the equation of this ellipse. Okay, so as I stated in notes, you're going to sketch just to get a feel of what's going on. 1, 2, 3, 4, 5, that's the foci, so I'm going to put a star. 1, 2, 3, 4, 5, -5. Okay, and the major axis length is 14, which means from endpoint to endpoint of the vertices is 14, which means from the center, you can tell just from this, the center is 0, 0. You can get that just from knowing the foci are plus or minus 5, 0. Major axis is 14, means from the center, I'm going to go right 7 and left 7. Because from that endpoint to that endpoint would be a total length of 14. So x squared over blank plus y squared over blank equals 1. This length here is 7, and that's running right and left with the x, so that goes here, 49, which means I'm looking for the b squared. And we're going to use our focal length formula. C squared equals big minus small. And C is a length always from the center to either star. It doesn't matter which one, the length there is 5. And 7 is your A. So we're going to plug information in. Okay, so 5 squared equals 7 squared minus B squared is what we're looking for. 25 equals 49 minus B squared minus divide. You get B squared equals 24. You don't have to square root because B squared is what you're looking for, and you get 24. Okay, that's 23. I am going to do 25. 25 gives you the vertices are 0 plus or minus 5, and a point on the ellipse is 4, 2. Okay, let's go ahead and sketch. Here's 5, 0, or 0, 5, sorry, and 0, -5. I can tell there from those vertices that my center is going to be 0, 0. X squared plus y squared equals 1. Okay, because those are vertices, not foci, I know the length here, and it's up and down, so that goes with the y. That's the b value, and it is 5, so the 25 goes there. A squared is what I'm looking for, and they give me a point, so I'm going to plug it in. Okay, so x is 4, so 4 squared over a squared plus 2 squared over 25 equals 1. I'm going to clear by multiplying everything by 25a squared. And I'm just doing that to clear my fraction, null equation. Okay, reduce. And I get 25 times 16, which is 400, plus 25 reduces a squared times 4, so 4 a squared equals 25 a squared. Subtract common like terms, 400 equals 21 a squared. Divide both sides by 21. A squared equals 400 over 21. And that's what I put here. Looks wonky, but that is the answer. 400 over 21. All right. That is number 25. My next one is number 27. Okay. 27. I believe 27 gives you a picture. See if I can get it in there. Gives you something like this. It gives you that this is 2, 0, 3, 3, and 1, 3, and the top point is 2, 6. Okay, regardless of which 2 points you use, the top and bottom or the right and the left, use your midpoint formula to find the center. And your midpoint, I'm going to use these 2 points here. You add your x's, 1 plus 3, and divide it by 2, and then you add the y's, 3 plus 3, divide by 2. That's your midpoint formula that you learned back in middle school. 1 plus 3 is 4, divided by 2 is 2. 3 plus 3 is 6, divided by 2 is 3, so your center is 2, 3. If you did 2 plus 2 divide by 2 and 6 plus 0 divide by 2, you'd still end up with the center of 2, 3. So x minus 2 quantity squared, y minus 3 quantity squared equals 1. All right, and then we have enough information here to find our a and our b. A is right and left because that's the x-axis, so from the center out this way is 1, and 1 squared is 1. From the center up this way is 3, because your center is 3, 3. From 3, 3 to 3, 6, or 3, 3, I'm sorry, your center is 2, 3. From 2, 3 to 2, 6, or 2, 3 to 2, 0, that length is 3, and 3 squared is 9. This here is your answer. Okay, 33. Vertex is 3, 1. Vertices are 3, 1 and 3, 9, and the length of your minor axis is 6. And I'm going to check it again. Vertices are 3, 1, 3, 9, and the length of your minor axis is 6. Okay. Okay, I'm going to redraw this just a little bit better. Okay, so 3, 1 and 3, 9. 3, 1, 3, 9. Those are my vertices, those are my endpoints. A midpoint formula to find the center, 3 plus 3 divide by 2, 1 plus 9 divide by 2, or you can just literally go down and boom, 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 count to the center. You get 3, 5 for your center. So x minus 3 quantity squared plus y minus 5 quantity squared equals 1. All right, 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. That's my center. From the center to either endpoint of my vertice is my b value, because it's up and down, and that's y. And 5 to 9 or 5 to 1 is going to be a b value of 4. So here is going to be a 16. So a squared is what I'm looking for. I know the length of the minor axis is 6. So from the center, I'm going to go out 1, 2, 3 in each direction. 1, 2, 3 in each direction. So that means this a value is 3, and 3 squared is 9, so 9 goes here. And that there is your answer for 33. And lastly, number 56. 56. Statuary Hall is an elliptical room in the United States Capitol Building in Washington, D.C. The room is also referred to as the Whispering Gallery because a person standing at one focus of the room can hear even a whisper spoken by a person standing at the other focus. Given that the dimensions of the Statuary Hall are 46 feet by 97 feet long, find an equation for the shape of the floor surface of the hall, determine the distance between the foci. So the whole whispering room is a real thing. Like if you've ever gone to museums or like science displays type stuff, they'll have whisper rooms where it's an elliptical shape, dome shape like roof, and if you're sitting on one focus and someone else is sitting in the other focus, and it can be like really far apart in the room, this person can whisper something really quietly, and this person over here that shouldn't be able to hear them can, because they're both sitting or standing on the foci. It really does work. I've seen it happen. Okay, so we're going to put ours at a 0, 0, and we're going to come up with an equation. It gave us that the dimensions are 46 by 97. So I'm going to do 46 right and left. So if it's from the center, I'm going from the center. And if I want to go 46 right and left, that would be 23 and 23. That would give me a total length of 46. The width, the height is 97. Half of 97 is 48.5. So I would go up 48.5 and down 48.5. And that total distance here would give me a total height of 97 feet long, total length. Okay. So this is just using the dimensions the book gave us. All right, x squared plus y squared, and that's because I set it up at the origin. The right and left length is 23, and 23 squared is 529. Yes, 529. And 48 up and down length is 48.5 times 48.5 is a big number. It's 2,352. Let me write that again. That was 2,352.25. There's your equation for the building. And it said, lastly, determine the distance between the foci. So I'm looking for the length between the two stars, so I need my focal length. C squared equals, I'm just going to do big minus small, 2352.25 minus 529. You can plug that in your calculator. C equals the square root of 18.23. And I'm just going to plug in the calculator just to make sure that my calculations are correct. Okay, so let me go ahead and do that now. You should be doing the same. Okay, yeah, 18.23.25, and then you are going to square root that, and you get 42.70 when you round. 42.70. So the length here from the center to that star is 42.70, but they're asking for the length between the two foci. It said find the distance between the foci, so you just double it. 42.70 times 42.70, or I'm sorry, plus 42.70, and you end up with 85.40 is the length between the foci. And that is it for this section of homework questions.